Hello, my name is Todd Cruikshank and I'm here with Dimitri Steinlen. Welcome to this presentation on optimizing wire harness manufacturing by using the capabilities of CATIA to create electrical wire harness design, manufacturing documentation, and drawings. In this short presentation, we'd like to provide an overview starting with today's challenges and current practices on wire harness manufacturing. Next, Dimitri will provide a short demonstration to show you how to improve the process and address today's challenges. Then we'll provide you with the Dassault Systems wire harness solution strategy to address the complete process from schematics to manufacturing in an integrated way. After that, we'll look at a customer testimony. Then we'll end with a short summary and provide you with the sources for additional information. A typical customer wire harness electrical process today consists of roughly 3 different steps: the electrical and electronic system design, the 3D wire harness design, and the manufacturing data preparation. For the creation of the 2D systems design, in many cases schematics or diagrams are used. The system may include lots of different software. However, they don't include the 3D harness design. In the 3D wire harness design phase, we have the creation of the complete representation of the 3D harness design in context of the product's digital mockup. In this case, we'll assume this is done with CATIA, either V5 or V6. In manufacturing data preparation, again, many different tools are used in the industries. The main challenge in this typical scenario are all the bridges and interfaces that are needed to provide the information from one process step to the next. Although different possibilities exist, they are all creating intermediate files that have limitations in sending information to the next step. There's no synchronization between the 3D harness design and the manufacturing documentation. This makes it cumbersome and very difficult to update the documentation while the design is changing. This is costly and time-consuming, and in the end it's difficult to optimize and guarantee the quality of the harness. The best you can hope for in this case scenario is the partial direct link between the 2D schematic and the bundle documentation. But even with this link, a lot of information has to be added manually to complete the manufacturing documentation. A physical mock-up is needed, with a negative impact on cost, schedule, and quality. There's no use of the 3D wire harness design to create accurate harness manufacturing data. The digital continuity is not maintained between the 3D harness design and manufacturing documentation. Whenever there's a change, everything has to be redone. There's also no automatic update of documentation when 3D or 2D design of the harness changes. Additional steps are required to create the form board on the shop floor. In short, it's very costly and time-consuming, resulting in a lack of quality in the final product. To improve this current best practice would be to have a manufacturing application that is closely linked to the 3D design, including automatic transfer of all needed information, synchronization, and update once the change is performed in 3D. In this case, there's no transfer of information between applications because they're all integrated in the same platform, sharing the same data describing the electrical wire harness. This process will improve design productivity through full associativity of the 3D and harness flattening models, enabling design synchronization and concurrent engineering. Automated generation of manufacturing drawings. Simplification of the CATIA 3D harness design methodology without the constraints imposed by downstream tools. It will also eliminate the following: the need for costly, inaccurate, and difficult to maintain physical mockups, inconsistencies between the 3D mockup and the manufacturing documentation, the cost for developing, implementing, and maintaining a software interface or bridge between CATIA 3D harness design and downstream tools for producing manufacturing documentation, the need to maintain a link between electrical schematics and manufacturing documentation, as CATIA electrical manufacturing preparation can integrate exported information directly from electrical schematics tools. In addition to eliminating these issues, It will also improve DMU and harness quality because the 3D shape of the harness and its environment are taken into account during planning for manufacture, resulting in better harness reliability and less maintenance. Also, the inclusion of the wires in the 3D DMU delivers better 3D analysis and simulation capabilities and the ability to manage harness variance in DMU. Now I'm going to turn it over to Dimitri to talk about the demo.
Hello, my name is Dimitri Steilen. If we look at the demo, we first will do an initial preparation, starting with the 3D, creating a manufacturing document which is completely linked to the 3D. Then we lay out the harness on the form board using very simple mechanisms, dragging and dropping, to align it and to optimize the layout, generating the manufacturing drawings, and whenever there is a change in the 3D, and we will show this in the demo, we do a modification and we update the harness documentation. So let me just start this short video about electrical harness manufacturing engineer. This is the product name in CATIA R2015X. As you have seen, we generate a manufacturing document, and here we see how easy it is to align the harness on the form board. The form board, the white plate in the background, representing the form board as is used in many cases in the production. So first aligning the harness by simply selecting the faces, and then if we want to do more detailed harness manipulations, it's basically by dragging, dropping, selecting parallel harnesses, and by selecting a corner we can easily adjust the radius of this corner, either by selecting it in space or giving it a real value. Also, more advanced functions like this umbrella is available to optimize the complete layout of your harness. When this is done, we have the harness in the 3D on a 2D plane. We can now simply, by using the drafting capabilities, create the form board documentation. We select the layout of the paper, we have a title block, and we start generating using some advanced automation scripts, automatic text generation. We create the full harness on the drawing, and by simply manipulating some of the text boxes we can create the full harness. Since we also have the 3D view, it's also of course very easy to have, in this case, a kind of isometric view. By selecting a plane, we can create a small drawing on top of the form board, which enables the manufacturing to have a 3D view and also see the location of all the connectors in space. So very easy steps to generate the drawing. Now if we have a change, for instance, we do a 3D modification, we add some slack to a specific bundle segment. Just by selecting the synchronization panel, it will automatically adjust the layout in 2D and the drawing. So a complete synchronized process.
Thank you, Dimitri. To summarize some of the key capabilities for form board layout design, first, you may have noticed automatic flattening of the 3D electrical harness, a simple click to flatten the entire 3D wire harness. Next, on the 3DEXPERIENCE platform, we have very intuitive and easy to use 2D harness layout tools to manipulate the bundle segment. The combination of harness design in context plus harness flattening guarantee accuracy, cost reduction, and easy installation of the final product. Some of the additional functionality is form board tooling design and partial flattening for complex rigid harnesses. Some of the key capabilities in CATIA electrical manufacturing preparation include automatic manufacturing drawing production. Border, title block, and revision table are defined according to the company's standards and reused. Predefined view style. Predefined annotations by object type. The ability to include additional views, for example, perspective views of the harness. Our strategic approach is to go beyond 3D design and manufacturing. We have implemented 2D schematic design tools very tightly integrated with the 3D wire harness design application to provide the complete process coming from schematic, going through the 3D harness design, to the fully integrated manufacturing solution available on the 3DEXPERIENCE platform. For the electrical roles that are now available in R2015X, first we have, of course, the CATIA 3DEXPERIENCE platform, which is a complete wire harness lifecycle management solution that can be quickly and easily integrated with existing tools and processes. Then we have the System Schematic Designer, SEF, which is an intelligent electrical systems design environment that drives real-time concurrent design and collaboration across all disciplines and stakeholders. The next role is the Electrical 3D Systems Designer, or ELG, which is an integrated approach to electrical 3D wire harness and cabling development that leverages the 3DEXPERIENCE platform to drive all design activities. And you have just seen the demo on the Electrical Harness Manufacturing Engineer, or EMP, which is an efficient and integrated solution for rapid production of all wire harness manufacturing information documentation in the form board. The evolution coming from CATIA version 5, we have the electrical harness flattening. In version 6, we started improving the user experience, making it very easy to manipulate the harness on top of the form board, and also adding performance improvements and key functionalities. This then evolved into the 3DEXPERIENCE platform, which added process simplification, extended synchronization, and drawing automation. A supplemental approach is also possible to continue the 3D wire harness design in CATIA V5 and to have your reference database with all your mechanical as well. You can import 100% of the data and reuse the 3D harness design in the 3DEXPERIENCE platform to create your manufacturing form board and drawing, benefiting from the new capabilities in the form board application. You can still continue to store your data and your CAD drawings for reference in your reference databases. Now we'll show an example of a reference story of a Dutch university racing team that competes in a worldwide competition with over 500 universities. They're using the 3DEXPERIENCE platform to design the complete electrical for their car.
Well, of course, everything we put in the car is very important because we try to build as lightweight as possible, so everything has to be really have its function and it shouldn't work without it. The electrical system is pretty special in a way that it really connects every electrical part of the car together. So there's also a lot of things where it can go wrong, so it should really be designed in a way that it should always function, even with a lot of use, since you always remove and plug in parts often. To control the motors of the car in a correct way, you need a lot of information about the car, so there's a lot of sensors distributed on the front of the rear of the car which communicate on a CAN bus to the ECU. Here all the calculations for the motor set points are calculated, and all these sensors all communicate on one big CAN bus through the wiring harness from the front to the rear. Next to this we also have a high voltage system. This means that all the current from the accumulator, which is at 600 volts, goes to the motor controller first, and that is distributed to all the other motors with AC voltage. Because the electrical harness inside the car is actually quite heavy in comparison with the rest of the car, about 2 kilos on a car of 155. There's pretty much to win by making a very efficient layout. So we used CATIA Electrical to lay out the wires in an efficient way so that all the splices are in the correct position and all the wires were as short as possible, so that we could almost halve the mass of the wiring harness of last year. Also, it's very important to have slack on your wiring harness on the right places, so only where you need to move the connectors and not in the rest of the wires. So we could really place it exactly the way we want and then put the slack on the right places.
The key value from CATIA Electrical is that we were able to quickly make a very precise design to accurately find the routing and the placement of the wires and of the connectors. We used flattening to design the drawings for the wiring harness, which we printed full scale, which was a big help during production. Then we calculated the length of the wires, and we used these during the production. We put them on the drawings. They were perfect in size, which meant we could really go quickly through the production.
We hope you enjoyed this short video. We're continuing to work with them in creating all the harness manufacturing drawings for the next generation racing car, the Delft 15, and it took less than 1 day to produce all the needed drawings to build the harnesses. Some of the key points in summary for CATIA electrical manufacturing preparation are: the use of 3D DMU information makes it very easy to quickly produce accurate wire harness manufacturing data, including all manufacturing documentation and detailed form board design and layout. There's full associativity between the 3D and the manufacturing documentation, and it provides an easy and safe modification process that eliminates errors. There's also easy synchronization between the harness 3D design and the flattened manufacturing representation, reducing process cycle time. There is a rapid return on investment through immediate improved productivity, the elimination of physical harness mockups, and improved quality of manufacturing information. Lastly, you have investment protection with the ability to integrate wire harness design and manufacturing processes with the next generation systems engineering tools and methodologies. If you'd like to request a demo, browse through videos, or to find out more information on the product itself, there's one link: www.3ds.com/electrical. We hope you have enjoyed this short webinar and that it gave you a good overview of electric harness manufacturing. Please don't hesitate to contact us with any questions. Thank you very much.